So let me prefix my demo with a few things. Obviously, Leo did a demo 2 weeks ago, and it covers a good chunk of what I'm going to cover again today, but I'm going to go into it in more detail. Plus, it's changed a lot. You know, much like the Dagger project, what was the case 2 weeks ago is not the case today. That's for sure. So a lot has changed on my side as I've rolled out more Dagger across my services. So to give you a little bit of context, I pretty much work full time now on my YouTube channel, which is the RawkodeAcademy. I have a mono repository, which has quite a lot of projects on it, from workshop automation to my URL shorteners to a studio product, email stuff. There's a whole bunch in here. And as I've been building out more and more Dagger, been able to have dependencies represented across a lot of my Dagger pipelines has become more and more paramount. And much like what Mark said, I hope that one day soon, a lot of what I have here will be deprecated and replaced by Dagger core. So there's some really interesting issues open right now that people should go and check out. The ones I'm keeping my eye on are obviously what's happening with extensions and the pipelines discussion. So you'll see that I've actually built my own pipeline logic, which I'm going to demo today. But issue, 4.4 something, I'm sure someone in the chat can link to it, talks about this in a lot of detail. But I'll definitely show my implementation at the moment. So we'll start with how does this work and what does this look like? So I'm going to go into my core infrastructure DNS project. And as you can see, I've made a few modifications. I am not going to log into my Terraform Cloud account or run a real plan or destroy. So these are all empty shell scripts because I don't trust myself during the demo. But I can run pnpm exec, and pnpm is really important in this demo because it's what actually makes this mono repository function in some pretty interesting ways. So I actually provide my own Dagger binary. It's not like a Go binary, it is a Node.js application, but it does some interesting stuff that we'll see. pnpm is a package manager that supports workspaces and mono repositories. So all of my projects can represent and talk to each other without ever querying npm, which is very important. You could probably emulate a lot of this in the Go ecosystem using the new Go workspaces stuff, although it's not something that I've dabbled with a lot. When I run pnpm exec, I tell it that I want to run the Dagger binary, which is just a Node.js application, and a few things are going to happen. First, we get a list of jobs. So we have pipeline discovery through this kind of I'm just going to call it a binary. I'm not going to try and caveat it anymore. We have pipeline discovery through this binary. It looks inside the project for a Dagger directory, where it will process any MTS file, which is a module TypeScript definition, or MJS module, JavaScript definition file. And you can see here that we get the ability to deploy, destroy, or plan. So I can run a plan. And while I've got Dagger people on the call, I'll complain that the connect function takes far too long. So I'd like to see that sped up, please. My projects all rely on secrets. As you can see right now, I have a prompt for 1Password to authorize this application to fetch the Cloudflare API and the Terraform token. So I'm going to approve that, like so. And my job finishes. So you just have to trust me that the plan did lots of important stuff, or we can run it again with a -l. So I just have this arbitrary flag added to my binary, which allows me to turn on the Dagger logging. So we'll run this one more time. And of course, it should just stay cached for everything. And we don't need to approve the passwords anymore because the 1Password CLI has actually cached this locally on my machine. So we do get access to all of the output as well. Excuse me. So I'll show you one more cool thing and then we'll dive into the guts of this. So for the pipeline discovery, I'm going to run it again. And I'm going to run destroy, and we get a confirmation prompt. So this is like a one-line change in the boilerplate, but I just think it's interesting that when we do automated discovery of pipelines, is that we probably want to enforce confirmation. And it's like the hackiest code in the world, but it just checks for a list of dangerous commands and filters it out. So I think based on that, we'll take a look at how this works. And then I'm going to move into another monorepository use case where we take a look at actually consuming this DNS configuration as a dependency. And we're taking advantage of some cool stuff with TypeScript and that we have the ability to do generic functions as well. So let me pull up VS Code. I can't see the questions anymore, so if there are any, please interrupt me. I'm happy to answer them as we go. So what does my job look like? Let's take a look at plan. So the first thing we should look at is this here. I'm talking too much. All right. So we have this interface called the Dagger command. And as long as the default export on our MTS file is a Dagger command, then the Dagger binary will expose this as a command that can be run on the CLI. It takes a few bits of information. One, a name, a description, which you've already seen in the selector, and then some execute function, which matches the contract that we specified, again, all using TypeScript types. The name is here, although I haven't used it yet, but you actually can just run Dagger plan and it won't prompt you, and it'll dive straight into running the pipeline. The execute function is what we have at the top here. And it just takes in a Dagger client and then this Tazuku dependency thing. Let me run it again. So if we take a look at plan, you'll see we get a really nice output where we have connecting to Dagger. Once it connects, it says we're going to run a TAF plan. We get each step in that plan represented as an indented task. And we have the ability to set status and outputs and errors and a whole bunch of other stuff on this that you'll see when I run it and the downstream project. So this all comes from this. And the really nice thing about this project is that we can just spin up any task that we want, and then it gives you another instance of itself where you can spin up subtasks, and it manages the hierarchy all the way down. All right. I like to be very explicit, so I create interfaces anytime I have to pass anything around in my pipelines. So we have type secrets. This is the secrets that are required. And we have a generic function which resolves these secrets and passes back the object. As you can see here, we call resolve secrets, passing in the type. And this was all 2 weeks ago Doppler, which you might have seen me talking about in the Discord, but I've now since started moving more stuff over to 1Password for a couple of reasons, but I'm not going to go into that in much detail just now.
And David, just before you move on, sorry, there was a question that came up, so I just want to make sure we didn't get too further down. Connor is asking for interactive prompts. He said, I'm guessing there's a way to instead specify some arguments for automation so that you can run this as part of some CI.
You can run this as CI. There's a top level build file, which has all the other builds as a dependency. And any flags that you would want to pass into that, which have to be defined using the commander package. I'll show that when I dive into the Dagger binary in a bit more detail. So I think I can answer that with code rather than talking.
Thanks, David.
Okay, so now we have our secrets. We have a typed object. I'm very happy. Oh yeah, there's one other thing here. Because we do automatic pipeline discovery, we don't actually know where a lot of the code is. We actually need like an absolute path. So with module TypeScript or ECMAScript, we have the ability to use import meta URL. And as part of my Dagger library that I have my own kind of like universe as it was with QWorld. That exposes a function called getSourceStar. So this will return a link absolute path to this current directory, which means that, sorry, my phone needs to go in silent. Which means that when I want to do an npm install or find the source, I can represent that using that path. So we grab the directory, we run an npm install. I'm running pnpm inside the container too. And this is really important because npm really sucks, especially in a monorepository. What actually happens is if we take a look at our package JSON, is this RawkodeAcademy Dagger package, which I have marked as optional, doesn't actually exist in the real world. And with npm, if you do an npm install, no optionals and no dev, it still has to resolve them for the lock file. and it will fail. So you actually can't build or install these packages inside the container. And pnpm allows us to kind of get past that with some logic it has. We're then using a generic function again to call the plan. This is exposed from my universe project, so it doesn't actually exist here. This is all part of my CDK library, which takes in the secrets, which is the type we use for the environment variables. It takes the client and the task so that it can spin more tasks if it wants, and then we're done. What's cool about this is we're also using a type system on the return. So you can see here that a plan actually returns a string, which I'm not using in this case. All right, so let's pop open my mini universe, and we'll start by taking a look at CDKTF. So this defines a config and a concrete config. The config is what we can kind of pass in optionally from the consumer side, and the concrete config is what we actually need to execute. I wish there was a nicer way to do this, but unfortunately there's not. And then we take in the type, and we just have kind of, because we're exposing this in environment variables, I do have to make sure that it's indexable. Hence we have extend record string. There's a lot of type stuff in TypeScript, as you can imagine. We're then continuing to use get sourcedir from our library. I'm using nixery.dev as a way to build arbitrary containers on the fly, which is pretty awesome. So here we have a container with a bash, nused, Terraform, and Node. We inject our environment variables, and then we chain together the whole bunch of scripts. So we run the Node.js, which does the pnpm install. We get the providers, so we do a login. This is just our setup function. And if we jump down into deploy, destroy, or plan, which are pretty much all the exact same function-wise or code-wise, we create a new Tezuku task with the description of what we're doing. And then we execute the entry point that we need for this particular thing. What's cool is that we can actually set an error, and we can set output. So if this task does fail, we use Tezuku to inject it in. Now, of course, when Dagger crashes right now, it kind of dumps the entire world into the console. So you have to kind of scroll past that first and then get to what you're looking at. So I'll just jump into the plan, and I'll say exit 1. And then from the CLI, we can do a Dagger plan. And hopefully it doesn't fail on me. Well, it should fail, but obviously the way I intend it to fail. Hopefully. Oh, I've invalidated the cache by changing that script, haven't I? I will give it 15 more seconds, and then I'll move on to show you the secret stuff, and then come back to it. Secrets it is. All right, we'll pop back to that in a second. So I also pull stuff out from 1Password. This is kind of cool, not from a code point of view. It's not doing anything unique or interesting. It's just a cool byproduct of the fact that Dagger now allows us to define our pipelines in code, and that I can run any code. Excuse me. So while all you cool Go folks are using Mage, over in the Node.js ecosystem, we have ZX from Google, which is a Node.js scripting library for writing shell scripts. So when we call resolve secret, what we're actually doing here is shelling out using ZX to run OP read, and we pass in the vault item and key that we want. Assuming that runs okay, then we can just trim the output and return it. So it's just nice that we are able to mix this world of TypeScript with shell scripting for all of our pipelines. And the resolve secrets rather than resolve secret actually just maps over and does this multiple times. So that's kind of cool. Now we have the big massive crash. And if we scroll up here, what we can actually see is that we get the error status from the CDK plan, and then we get the output printed as an error message, and then it's followed up by the Dagger crash. So cool stuff there. Is there anything else cool worth showing here? No. So that's my little mini universe. At the moment, I support my secrets library. I have my old Doppler support for speaking to the Doppler API. I have fluxtd commands, stuff for publishing comments on a GitHub issue. Well, that's just the type, the code's in another file. And my ability to execute Pulumi as well. All right, let's take a look at one more pipeline. This time I'm in my projects folder. Oh, my terminal's just crashed. Oh. All right, okay. RawkodeAcademy website. So this is just the website that we have, which also has its own Dagger pipeline. And this one actually does the GitHub comment. So if we detect that it's a pull request, it will grab the URL from a Dagger output and then post it on the GitHub issue, which is quite nice. So we start grabbing some environment variables, and we have this status indicator for the user. If they're not an interactive environment, it gives them that really early heads up that it's a preview deploy or not. And then on the terminal, it just lets me know what I'm doing as well. We're using this Tazuku everywhere, but you can see here that we have our first dependency. So that's actually, we can't spin up the website if we don't have a zone on Cloudflare and a pages project created. So we pull that in through pnpm, which is here. So I'm just consuming the Dagger job deploy as a dependency, which is quite nice. The other cool thing about this being TypeScript is that we can define what the return type in all of this is. So when I run Pulumi commands, I return like a map, which has all of the outputs from Pulumi. The same for CDKTF. And for Cloudflare runs, maybe I just want the standard out to come back for some sort of interpretation. We then grab our Cloudflare token, we do our npm install, and have some hard-coded account IDs, but that's perfectly all right. And then we do the pages published. So after we built the Astro build website, we publish it to Cloudflare. And then grabbing the website URL with regex. And then if we have the pull request condition, we're using the OctoKit library on GitHub, which just allows us here to say OctoKit create comment, parsing the pull request number from the regex and sending the preview URL. So I don't run this in GitHub Actions right now for a few different issues related to secrets, which are hopefully being worked on any moment now. But I'm very keen to get this back as people actually make open source contributions to the Academy website, which is good, but I want to be able to give them that preview URL whenever they do. So let's run this. Wow. Dagger. We just have the one job, but we'll see that it does call and execute the core DNS, or at least the core infrastructure DNS repository. So it's fetching those secrets, doing the plan. Oh no. Oh yeah, I've got the crashing. Let me fix that. The other cool thing here is that these jobs all run in parallel unless you explicitly tell them not to. From the Tazuku thing, we can see the status here that this is a main branch deploy. And we have our dependencies ensuring this domain exists. So you can kind of annotate the jobs as well so that you have this kind of nice feedback loop to other people that are using the code. So in our deploy job on the website, yeah, like, you know, anyone can read this and see, oh, this is a dependency because of this reason. And then it spits out the URL for the production deploy at the end. So it all works for pnpm. I have my own universe, I have secret support, and I'm doing monorepository dependencies. I'm pretty happy with it. I think it's working well. I think it's going to be a lot nicer over the next few weeks and months as new features come, but I'm happy to answer any questions that people have.